Hi everybody. This week we're going to talk about databases. Now for CS546, our database of choice is going to be MongoDB. We choose MongoDB because it's a very simple to use syntax in order to pick up, and it integrates very well into the Node.js environment. It uses JSON to store documents, or JSON-like structures to store documents, we should say, which are just JavaScript objects. It uses JavaScript object syntax to query for documents and insert them and create them and read them and update them and delete them and so on and so forth. And furthermore, because it's a document-based database, we don't have to worry so much up front how we want to design our database. So it allows us to be flexible, it allows us to make mistakes and correct them, and it allows us to kind of focus on the fact that we're using a database for web development rather than focus on having to be experts of databases, because that's not the scope of this course. That's in the database courses in this skill. So the first thing you have to know about a database is just from a fundamental standpoint, all we're going to be doing with databases is storing, creating, reading, updating, and deleting. We're not going to be doing fancy indexes in this course unless you want to. You could always feel free to add an index for performance reasons. But for the sake of CS546, we're going to be simply using them for the basic for operations. And we're going to see how they fit into web development and how web development is very closely tied into reading databases. It's what we do whenever we hit any website nowadays. There's always a database involved. Now our example this week is going to be dogs that have blogs, because humans with blogs are kind of boring, so let's have some dogs write blogs this week. And let's go through a little bit about the structure of a database, and particularly a document-based database, because that's going to be a little different than what we're used to if you come from a SQL background. The first thing you should know about a database is, simply put, it's where we store our data. And you can organize databases, you can have multiple databases per application if you wanted to. A little hard to break that up, but it's entirely possible. And inside of these databases you can have multiple collections, and each collection fills documents. So just strictly from top down, we have our database engine, which is going to be MongoDB. Now MongoDB is going to store a number of databases. There'll be one for the lab this week, there'll be one for the lab next week, there'll be one for your final project, and so on and so forth. If you wanted to make a personal program, if you wanted to experiment on your own time, you'd make a database for your personal program. Now, MongoDB needs to be installed on your systems. It needs to be installed on any systems that are running these applications that you're writing. There's no embedded MongoDB right now. Well, there's no really good embedded MongoDB. Much like how you need MySQL on a server to run WordPress, you're going to always need to install Mongo on a server that requires Mongo. It's not like SQLite where you can use a flat file to store your data, unfortunately. However, despite that, it's a very useful technology. So Mongo stores everything. The database engine has many databases. And like we said, those databases usually serve one purpose. But every database can have multiple collections, they're called. Now, a collection is specifically just a collection of related content. Now, the beautiful thing about NoSQL databases, is particularly ones that are document-based, like Mongo, are that oftentimes you don't have to define a set schema per document. Each document can have slight differences in them. For example, if we had blog posts, if we were storing blog posts, and there were two types of blog posts maybe, FAQ how-to blog posts and just general written up blog posts, we could store them in the same collection, which is similar to a table in SQL databases. However, we can have a few fields on the FAQ type of entry that we don't have on the normal blog post entry. But they could still be in the same collection because they're still very related. They're the same type of content. So you'll be thinking of your collections in terms of content. Every entry in a collection is referred to as a document. Now, every document has two things. It has, one, a series of fields, where one of them is specifically an identifier. And when I say an identifier, I mean MongoDB by default will insert a special field into every document called _ID. Now you can provide this ID when you create the document, but it's not necessary. It will auto-generate one for you, and just showing you a little bit of the code now, just a preview. We'll get more into that in the next video. And you'll be able to get it even if you don't insert it. In here, we don't define an ID, but we insert a document, and we get an ID back due to the insert operation, which you'll see very shortly. Now, every document can also have multiple fields. In our case, if we just look here, now even if we don't know much about it right now, we're storing in the dogs collection an entry for a dog that's just a JavaScript object. Now, there's two fields on this, name and breeds. Breeds will be an array, and name will just be a string. And so every document we have will have some fields. Fields can also be something called a subdocument. A subdocument is just an object inside of your document. So if we wanted a document such as this, instead of just having name, breeds, we could also do something such as a profile, where inside of that we store, let's see, profile, hobby. Because they're a dog, we'll say playing fetch. And let's see, what else do dogs like? Favorite food, of course. And we'll say cheese, because my dog loves some cheese. And so we could store the data just like that. We don't need a second table to store profile information. We don't need to store a ton of documents, a ton of columns, because in a table that says one for hobby, one for favorite food, and have a table with 100 columns. Instead, we can just store documents and store objects just inside of documents as if it was just a plain old JavaScript object that we're working with. Now, MongoDB, we're going to focus on 4 basic operations. They are insert, find, update, and remove, which is essentially create, read, update, and delete, which are the fundamental actions of any web application. So let's take a look at this. Here we have in Node syntax using the MongoDB driver, which we'll get into very shortly, how to do all of those. Now, when you insert, you just insert a document. And a document is just a JavaScript object, which will get serialized into binary JSON, but that's neither here nor there. We don't have to get that level. When we want to read a document, we can just query for one. When I say query, I mean we define an object that looks like an object. How a document is stored in a database for matching fields. So for example, if we wanted to find the dog that has an ID that we provided, we just tell Mongo to find one document where the underscore ID field is equivalent to the ID that we provided. It'll return the first dog that matches that criteria. The next thing we see is removal. Down here, we remove documents by doing the same thing as finding them. We say remove one document. There's also the ability to remove multiple. There's also the ability to remove multiple documents by using another function, but we'll see that in more advanced Mongo topics. And finally, we can update dogs. Now, there's 2 ways to update them. First one we're going to see this week, which is just for providing 2 parameters to the update1 function on a collection. And the first is going to be, yet again, another document that describes matching fields. So in our case, we're saying update the dog, where the underscore ID is equivalent to the ID we provide, Mongo, and set the document to be anything we provide it to be. So in that case, we're doing a full replace, which is not the best thing to do, but it's not the worst thing to do either. And we're going to just pass it a new document to replace it with, and the underscore ID field will not be replaced when we do that. So those are going to be the fundamental operations in Mongo. Pretty simple stuff. You'll get used to the syntax as you use it, and I'll be going over the code in more detail in the following video. But finally, there's the little fact that to perform these operations, there's a couple of steps you need to take. Now, your Node application is going to need to connect to your database. Now, we're going to be using a special module that you can use exactly how I created it. You can copy this, just changing the database field for all the assignments coming forward. We have to create a connection to our Mongo database. Now, in our case, as we grow more settings, however, we may abstract this out, pull it out, put it in a settings.json file or a settings module of some sort. That's neither here nor there for now. In our case, we need a server URL and a database name, because we're going to compose a URL that starts with MongoDB instead of HTTP, and the actual URL to connect to Mongo is going to have the database name attached to it. So we have to then create a connection to the database. Now, this is going to be a little trippy of a syntax here. It trips me up even to this day to look at it, because we tend to only want one database connection open. So the easiest way to do that and make it asynchronous is to use the connect function and return a promise that resolves to the database, which is all we're doing here. Now you might say, okay, why do we do this if not connection bit? That's because this module should export a function that will return a promise that resolves to the database. That will enable you to have one connection passed around and will allow you to just cleanly format your code, as you'll be able to see in dogs. Well, actually, as you see in Mongo Collections. Now, in Mongo Collections, I'm going to show you guys how to actually get a collection for a particular type of data. In our case, for this week, for our demonstration purposes, we're going to have dogs and we're going to have posts, because our dogs are writing blog posts, because if dogs could, they really would. Now, you also only, just for simplicity's sake, we're making it so that you only have one reference to each collection per application. Now, this is another section that you can copy and paste. However, you're going to need to update this tiny export section for every collection you make. This will allow you to have one module that has access to your connections if the database was successfully connected to. In our case, we're doing some very fancy code right here.